Hello everyone! This is the last video in a series about probabilities. And after all the experiments and simulations, in this video we are going back to just calculating probabilities. So I will start by reminding you of the basics of that, and then I will show you two ways in which you can count systematically, since we will need to count options very often. So I'll show you the tree diagram, and I'll show you that in some cases the table will be more useful. So let's remind ourselves first of all, how did we calculate probabilities? Well, what we did is we count the total amount of possible outcomes, and we count the total amount of wanted outcomes, and we divide them by each other. So for instance, if I want to know the probability of throwing a 6 on a regular 6-sided die, I know there are 6 possible outcomes, 1 to 6, and I know there's only one outcome that I want, which is the 6. So my probability would be 1 over 6. What is important here is that if you're counting all those outcomes, that they're all equally likely. So for instance, if I want my probability of throwing a 6, I cannot split it up into 6 and not 6. That would imply that there's two different options, and that then the probability of throwing 6 is 50%. So that way it does not work. We have to be sure that the probabilities are all equally likely, or the possibilities. In the book, in the exercises, you will see that used here, for instance, where you can't just say the option between blue or red. You would have to list blue, 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 red, red, because there are 3 blues and 2 reds, and that will give you the proper probabilities. In these cases, it's fairly obvious, but it isn't always. So it is always important to think about, are all the options equally likely or not? So that's just a basic start. But obviously, when it all comes down to counting the possible outcomes, we sometimes need some structure. And the first one that we're going to use is tree diagrams. And this is especially useful if you have a probability experiment that has multiple steps. For instance, if I'm tossing 3 coins, 1, 2, 3 steps in there, then what I can do is I can write down each of these steps in my tree diagram. So my first coin can be a heads or a tails. My second coin can also be a heads or a tails. And my last coin can be heads or tails as well. And I add them in each of the branches because after throwing heads and heads, I can throw heads or tails on the last coin. But if I've thrown heads and then tails, I can also throw heads or tails. If I throw tails and then heads, I can get heads and tails. Or if I get tails and tails, I can also get heads and tails. And I could write them all out at the end. I'm not going to do all of them here. But this way I can count that I've got 1, 2, 3, 4, 5, 6, 7, 8 total options, and I can count how many I actually want to get any probability. So that's a tree diagram, and it can be very useful, but sometimes it gets a little messy. Consider, for instance, if I'm rolling 2 8-sided dice, and maybe I want to know the probability of rolling 10. Well, then for my first die, I already have to split this up into 8 different branches. And sure, I don't have to draw the whole thing for my second die to get an idea. I can just only draw it on the first one. And know that this is 2, 3, 4 as a sum if I add them together. And it gives me some idea of what the total amount of options will be, because I have 8 options here, and for each option I have another 8 options here, so I do know that my total amount of options are going to be 64. But it starts to get very, very difficult to have a good overview of what results you're going to get, about what happens when we add the 2 dice together. So this is a point where sometimes the tree diagram can still be useful, but often it is actually more useful to turn it into a table. So this is especially useful if that tree diagram becomes too large, if there are too many options. As I just showed, if I would have the whole tree diagram, I would have to go up to 64 different branches. That is too much. So let's have a look at rolling 2-sided dice again, but now in a table. Then what I could do is I could make a table like this. So I have my one die on the one axis and the second die on the other axis. And then I just have to fill in my table to find out what happens when I add them together. I'd forgotten that that was going to disappear. And then I immediately have an overview. I still know that I have to do 8 times 8 to get the total amount of options. Because, well, there's 8 options here and there's 8 options here. But this time I can easily see how many options I have to throw 10, namely 7 options. So I know that my probability to throw 10 is 7 out of 64. So this is especially useful if there are just too many options. There is one drawback, which is obviously I've already used my horizontal and my vertical axis. I can't really make a 3D table. I can't add anything more. So this only works if your probability experiment has 2 parts. So for instance, the 2 dice would work, but I can't really make a table, or not easily at least, for my 3 coins. So that is all I wanted to say about probabilities for now. We've seen how to calculate them, and we've seen that we can count systematically using the tree diagram or the table, depending on the situation. And now it's time for you to put this into practice.